Welcome to PK's classes. Today we are going to study about gel electrophoresis. So electrophoresis is derived from two words, electro and phoresis. And phoresis means migration. And electro, it will provide electric field. So when electric field is applied, the charged particles will move to opposite electrodes. Suppose one side it is anode and the other side it is cathode. So anode is the positive electrode and cathode is the negative electrode, and they are connected through electricity. So it will provide an electric field where the positive charges will move towards the cathode and the negative charge will move towards the anode. So suppose we have all negative charges, then and if we provide a medium, say gel, then based on their size they will move. Suppose at one side, suppose this is negative charge we have put here, then these negative charges will move towards the anode, the positive electrode, based on their size. So here size and charge, these are two factors mainly affect the migration. Besides these two, binding affinity can also affect. So in electrophoresis we provide an electric field through two electrodes, the positive electrode or anode and negative electrode or cathode, and if we put the charged particles will move to their opposite electrodes based on their size. This is electrophoresis. So using this is you can see the gel electrophoresis instrument where these two electrodes are there. One is the cathode and the other is the anode. And exactly you can see here, these are the two electrodes. This is the casting tray where the gel is put, Agarose gel, say it is put there. Then the well comes where the DNA to be separated are put, and this is the voltage source, and this is the gel box. So in this case we can say that gel electrophoresis is a molecular biology technique where we use it to separate nucleic acids like DNA, RNA, and also the proteins. And nucleic acids like DNA, RNA are used because they are negatively charged. So if it is negatively charged, then they will move towards the anode. So we use electrophoresis to separate nucleic acids like DNA based on their size. Similarly, the proteins charge depends on the pH of its environment. So basically one criteria is there, isoelectric point. What is this isoelectric point? The isoelectric point is the pH at which the protein has net charge of 0. So 0 charge, the pH at which the protein has 0 charge, that is called the isoelectric point. So the pH can be either more than the isoelectric point or less than the isoelectric point. So suppose pH is less than the isoelectric point Pi, pH is less than the isoelectric point, then the protein will behave as positive charge, and if pH is greater than the isoelectric point, then the protein will behave as negative charge. Mostly the small proteins are usually positively charged and the large proteins are negatively charged based on size also. So proteins how we will separate? For that we use a denaturing agent like SDS, sodium dodecyl sulfate, which makes it negative, dodecyl sulfate, which makes the protein negative. The protein is made negative charge by using SDS. So we can use DNA, RNA because they are negatively charged, and we can make the protein negatively charged by using SDS, the denaturing agent, and then we can use it in the gel electrophoresis, and at one end we will keep them, and based on their size they will move towards the anode. This is the principle behind the gel electrophoresis. So you can see here, these are the sample wells, and if you put the sample like DNA or protein there, then they will move towards the positive electrode or anode. So this is the direction of movement. So you can see, so this is the electric field created because one side is the cathode and the other side is the anode. We have the power supply on, so the electric field is applied. Then we have loaded the DNA sample say here, and the Agarose gel say put here. So depending on the gel used, we can have two types of gel electrophoresis. One is Agarose gel electrophoresis, and the other is polyacrylamide gel electrophoresis. So Agarose gel electrophoresis or edge, and polyacrylamide gel electrophoresis or page. Two types of gel electrophoresis are there, and this page we can again modify it to SDS page. As I have discussed, SDS, a denaturing agent, sodium dodecyl sulfate, can be used, and it can be SDS page. So this is Agarose gel put here, and when we put the DNA samples with the electric field on, then the DNA based on their size will move, and if in one well we put the marker DNA, then we can also compare them. Then how to look for them? Suppose you will put the UV radiation, UV transillumination, then we will see they will fluoresce and we can compare them. So this is one example, and we'll see that the smaller size DNA will move faster, and we will see this side on the upper side, and the large size DNA will remain close to the wells. In actuality, it looks like this. These are the wells, and these are the after movement. So this is smaller size, and this is larger size. And if we see the relationship between DNA fragment size and distance, so the distance migrated, as higher the distance of migration, the size is less, and the curve will be like this. So molecular size is higher at the lower distance, whereas as the distance progresses, the size decreases. You can see 1000 base pairs near to the well, whereas 100 base pairs distant from the well. So this is a vertical one. You can see this is a horizontal one. This is horizontal one. Mostly the Agarose gel electrophoresis is horizontal, and the polyacrylamide gel electrophoresis is vertical. So the run is vertical in case of page, and we can see these are the wells. These are the wells, and in the well we have put the sample, and then the larger fragments near to the well, high molecular proteins, and the distance, the smaller fragments, which are the low molecular proteins. So as we have already discussed that in polyacrylamide gel electrophoresis, the proteins can be separated, and mostly for protein separation we use page or its modified version SDS page, and for DNA mostly we use Agarose gel electrophoresis. So let us see the overview of the Agarose gel electrophoresis. So we can take some agarose and buffer, boil in a microwave, then we cool it to the room temperature, and it will be set, and we can insert the comb to prepare the wells. After it is set, we can remove the comb, so the wells will be there. So this is the finished gel with wells. Then we'll put the DNA samples, different samples in different wells, and one well we can put the markers, the marker DNA for comparison purpose. Then we'll put the electric field, and it will run, and we can separate, and we can compare them with in a standard curve, and we can know or we can separate the DNA based on their size, or we can see what are the DNA fragments present, and we can also use them for gene sequencing based on the pattern in which they are separated. You can refer to our gene sequencing video for more knowledge. Next, this is page or polyacrylamide gel electrophoresis, where we can take the protein sample and heat it with SDS and mark up to ethanol, and they will become negatively charged. So we call SDS as the anionic reagent. So it makes the protein negatively charged. Then we'll put the sample in the well, and this is a vertical one. So there will be slab of the polyacrylamide gel, and then the proteins will be separated based on their size. High molecular weight proteins will remain close to the well, whereas low molecular weight proteins will move towards the anode. So this is all about gel electrophoresis. Thank you.